All right. Up next, we'll have Herbert Bean presenting a report on the bomb calorimeter from Experiment 2.
All right, good evening. My name is Herbert Bean, and like I said, I'm going to be doing Experiment 2 for the bomb calorimeter. All right, so the objectives for the experiment were to become familiar with the physical principles, procedures, and techniques associated with the oxygen bomb calorimeter. We wanted to determine the thermal capacitance of the calorimeter, and then we wanted to determine the gross heat of combustion of the sample provided. All right, I guess a little theory. We wanted to observe the water temperature. Basically, we were doing, we were finding the calories associated with the sample, which is basically the it's a rising temperature of water. So basically, 1 degree of water, once it rises 1 degree of Celsius, that's what is going to be equal to a calorie. I put engineering application here, but it's kind of like a nutritionist application because these are the people who actually do these type of tests and then figure out the amount of calories to be put on package labels. And then so the goal was to calculate the thermal capacitance of a sample, and we ended up doing some candy. So just I guess a little experiment recap. This is the apparatus, as we all know. So we have the water bucket, and over here at 2, we have the actual bomb, and 2 goes into 1, which is from 1A to 1F. We just had the bomb, and then we had to cut our own ignition wire, which is B1F. We had to make sure the ignition wire was actually placed we had to make sure the sample was actually touching the ignition wire to make sure that the ignition actually went off, and then we had to, once the bomb was placed, we had to place inside the water container. We had to make sure we connected the two electrode terminals at the top, and then once we actually placed the lid inside, we had to make sure the spinning fan wasn't hitting the side. That way, well, we had to listen for it to make sure it wasn't hitting that way. The ignition actually ran smoothly. And that was the fan was the actual water stirrer. So, in terms of results, basically the only thing we were collecting were the actual temperature over time. These 2 graphs went over a number of seconds, and then we were just collecting temperature over time. So this is the benzoic acid tablet. That was basically what we were measuring against. The starting bath temperature, we had 25.86 degrees Celsius, and then the final bath, 28.28, and then that delta T was going to be 2.42. This should be degrees Celsius, not seconds. And then on the other side, for unknown samples of candy, we have something similar, but just the delta, the change in temperature in degrees Celsius is going to be 1.35. So in terms of interpreter results, so I just used the internet to find the heat of combustion of benzoic acid, and I got 26.43 kilojoules per gram. I used the first law of thermo, and then just manipulate the equation to get MCV of the entire calorimeter, and then use that to find delta T. This should be degrees Celsius and not seconds, to find that of the calorimeter. And once you find the 11.54 for the calorimeter, we went ahead and then just used that to find the heat of combustion for the sample. And then I got 15.58 kilojoules per gram. And then I just converted the grams to calories, and then I tried to do the offset that we had for the ignition wire, and because once we burned the ignition wire, once we had the ignition, the entire ignition wire did not burn. When we did some of the when we did our last 2 tests, so we had to account for that, and then I just accounted for it as for 19 calories, which was found using the converter on the little small wire, which is the wire wrap, which just gave us like a centimeters per calorie type deal.